Now, I'm going to tell y'all, stay with me. Just because it takes me 30 minutes to walk through one example does not mean they're going to take you that long. Remember, I'm explaining them as we go. Just stay with me. Okay, so we're skipping 4.2 for right now. We'll come back to it. This is 4.3. This is polynomial division. Okay. Pascal's triangle, binomial theorem, expansion. It's a way that you can, if you have a binomial, two pieces like 5x plus 3 and you raise it to like the 5th power. It's ways that you can multiply that out without actually multiplying out. First to simplify to the next, simplify to the next, yeah. Okay. It's just a little method for that. It's Pascal's triangle with some neat little tricks there. But I feel good about skipping that for right now and moving to this, getting all the operations down, then we'll come back to it. All right, polynomial division, here we go. If you remember long division from elementary school, this will be a cinch for you. Okay. Now, before I get into actual long division, let me talk about dividing by a monomial first. So I'm going to do a couple scenarios here. Divide by, what's monomial mean? One piece, right? So maybe I have something like this. Come on, pen. 6x to the 4th, y to the 3rd, plus 12x to the 3rd, y squared, minus 18. This looks a lot nastier than what it actually is. Everybody divided by 3xy. Do you see why I said dividing by a monomial? Okay. Monomial meaning one piece. There's only one term on the bottom. When it looks like this, what we're going to do is we're going to split into separate fractions. Separate fractions and simplify. Okay, if you can see it without actually splitting it, that's fine too.
After you simplify it, all of you combine that together?
You can.
Or do you just do them two fractions separate?
You can combine them if they'll combine, yeah. Can you what? You're talking about taking out a GCF out of the top? I mean, you could, but it's not going to do you any good on the bottom for that. So you're taking an x squared out. Yes, but it's not going to do you any good in your simplification process there. Okay, so looking at this, this is the same thing. Remember, when I have multiple pieces up top that I'm adding or subtracting and just one in the bottom, I can split this up this way, right? And you're right, whenever I'm done, if I can put them back together, that'd be great. But I really want you to see this. And I don't know why students... What did I put to the third? I don't know.
After you have them all divided, do you choose the plus and minus?
Yes. All right, so as I look at this to simplify, all right, look at the first fraction. This looks like what we did last night with our properties of exponents, right? 6 divided by 3 is 2. 4 minus 1, 3 minus 1. The denominator went away. That's convenient. How about the second one? Does everybody see what we're doing? How about the third one? Y to the 0, which is 1, which don't have to include, right? Do you see how nicely this simplified down? Okay. I don't even have any more fractions to combine. Okay. But I want you to see that we can split this up whenever we got something on the bottom like that. We can split it up over that monomial on the bottom. Okay. All right, Josie, are you okay? I'm sorry.
This one.
All right, that's easy. Let's do long division. All right, so when we have polynomials divided by polynomials, let's say that I have x squared plus 3x minus 40 divided by x minus 5. Okay, well, fraction's not going to do us any good here. So here's what I'm going to do. I want you to think back, and I'm going to try to run this alongside so you see. I want you to think, give me a, let's say I had 127 divided by 5, okay? Think back when you were in whatever grade you learned long division, and tell me how you would set that problem up. 127's on the inside of your little house, 5's on the outside, right? We all remember that? Same thing over here, okay? X minus 5 is going to be on the outside, and inside my little house is going to be x squared plus 3x minus 40. Now let me give you a warning here, okay? You have to include what we call placeholders. Now what placeholders are is if you have, let's say that I had x squared minus 40 and this 3x wasn't here, okay? Whatever my biggest exponent is, I have to have every exponent below that, okay? So if my biggest exponent was 5, I'd need to make sure I had an exponent of 5, 4, 3, 2, 1, okay? If you don't, you need to hold the place with a 0. So for example, and I'm going to scroll over here just to show you and I'll come back. If I had 3x to the 5th plus 7x to the 4th minus 5x cubed plus 7. I'm missing some things here, and I would need to make sure that I held their place. So this would become 3x to the 5th plus 7x to the 4th minus 5x to the 3rd. Uh-oh, I'm missing a power of 2. So I would do 0x squared. I'm also missing an x plus 7. See what I mean by placeholders?
Yeah.
Okay. So make sure you check for placeholders. And of course, the first one, the example that I'm giving you first, we don't need any placeholders. But I will do one that has to have a placeholder. All right. There we go.
So if you don't have a line or stuff, you have to put 0 into that?
Look at the first example, the 127 divided by 5, and tell me what your first step is that you do. You say, what can I multiply 5 by to get as close as I can to 12, right? And you write it up here, okay? Come over to your other example. We're only going to be looking at first terms. That's the biggest difference here. What can you multiply x by to get as close as you can to x squared? X. Okay, this is going to be my x squared column. This is going to be my x column and my constant column. Neatness here is what's going to save you. Okay, all right, so I'm going to put x here in my x column. Anybody confused so far?
Yeah.
Is that your regular x column?
Why don't you put it above the x squared? Yeah, that's not good.
She don't have an
X squared, everything that's x, everything that's constant. You're going to keep them all together in columns.
Oh, wait. But that x doesn't go with the 3x, it goes with the x squared? Because since it's one x times x.
You didn't, like when you came here, you didn't put that 2 over the 1. You put it over the 2 here because it's the tens column. It's going to be 20 something. This is x, it goes in the x column. Just keep them lined up. Vertically lined up. All right, look back over here and tell me what you do next. Now, you did something before you did that. How did this multiplies through right here, right? So I'm going to do the same thing. I'm going to multiply through. Now, I'm multiplying to all of this, not just one thing. Okay? So here I multiply through and write it down here. Same thing. X times x minus 5. So it's really x times x minus 5. what do you get? X squared minus 5x. Again, keep those columns lined up. Anything vertically in this column is going to have a squared on it. Vertically here is just going to be x. Do you see what I'm doing?
Yeah.
Okay. Looking back at your easy example, you subtract. You're exactly right. Now, when I subtract here, think back to your homework last night, subtracting polynomials. I'm not just subtracting the first term, I'm subtracting everything in parentheses, right? So, remember how we distributed that negative? Negative, and we changed all the, this pen's about to get on my nerves. And we distributed that negative through, right? X squared minus x squared cancels out. 3x and 5x. Okay. Everybody with me? So your next step, you go back to the original problem. You bring down the next term, right? So I'm going to come over here. I'm going to bring down the next term. Bring its sign with it. Now what do you do? Your process starts repeating, right? What do you multiply 5 by to get 27? Okay, well, what do you multiply? Again, first terms. What do you multiply x by to get 8x? 8. Positive 8 or negative 8? Positive. It goes up top. Do the process all over again. Multiply around. So 8x so they do 8x minus 40. We change all these signs, but what suddenly happens is I get a 0 here. That 0 is what? What is that 0 called here, though? A remainder. Okay. This happened to be a factor, which is nice. A factor is whenever you divide and you get no remainder, right? But if I came back over here and I finished this problem, I would find that I have a remainder of 2. What do you do with a remainder in a long division problem? No decimals.
R2.
No R's. A fraction. How do you do it, Callie? Close.
Or you do like, you do whatever's like on the top.
You added it, and, yep. Okay. So if this had been a number, I would do whatever that remainder is over what was on the outside. The steps are exactly the same.
Remember like the clock thing over
Yeah.
there?
Clockwise.
Take your time. That's what we did.
2 over 5.
Wait, so you just put 2 over whatever the number you divide? Okay. Or whatever number. The dividend, what is the word for it? Because like dividend is inside. the-
Divisor, quotient, and dividend.
Yeah, divisor. So it's.
Y'all ready for this one? By the way, before I actually do this next one, if you see something like dear, I don't know if it's the pen or the batteries, but both pens are doing this now. If you see something, and I'm going to set this one up like this, x to the 4th plus x to the 3rd minus 6x squared minus 4x plus 14, times x squared plus x minus 2 to the negative 1.
So is that dividing?
That is dividing. Why is that dividing?
Because you put it on
The negative exponent moves it down to the bottom. It becomes a fraction. Up top is the first parentheses. Down on the bottom is the second. Okay. All right, look, what does it mean when you have a negative exponent? And it becomes positive, right? Is that a division problem now? Why, yes. Yes, it is. Because every fraction is a division problem. Yes.
Do you have placeholders?
Yes.
Dividing.
You want to have them anywhere you need them. Anywhere, outside, inside, wherever you need to have them. You don't need any placeholders for this one. What goes on the outside? What goes on the inside? We do not need any placeholders. You are absolutely right. And so we start the process. Most students like this because whenever you see it being done right next to a regular long division problem, and you see that the steps are exactly the same, this is just way more complicated. It makes sense, though, to you. All right, first terms only. What do you need to multiply by to get that? X squared. Where should I put it?
Above the X.
Above the squareds column, right?
I thought the squares column was above. No.
Under the-
So then you just wear a square in the
I
top?
understand the columns now.
Okay, say X4 wasn't there, and you had X2 and X3, and you moved it down to the one that's just there.
It wouldn't be X2 and X3.
It's the one that if you
Right.
open it, you simply close it.
You're right, Meg. Adea said if you had X2 and X3, would you just move down? And Meg said you wouldn't have X2, X3, you'd have X3, X2. But you couldn't have X2, X3. Because we've got to be in standard form. Biggest exponent down to smallest. All right, let's multiply around. It's got to hit everything, right? So X squared times X squared is X to the fourth. It goes in the column with the powers of 4. X squared times X, X to the third, so it goes in the column with the thirds. X squared times negative 2, negative 2x squared, right? But this is all subtracted, which means I need to distribute that negative through, right? Negative, negative, positive. Your first terms should always and forever cancel out. That's the reason you chose the value that you chose to put up top. All right, gone. Ooh, nice. Gone.
On with that one.
Negative 4x squared. Yep.
Do you only bring down the negative 4x? Or is it negative?
Yeah.
We don't bring that one in.
Not yet. Just like the other, you bring one number at a time, bring one term at a time. Yeah. Yes, absolutely. What do you multiply this by to get negative 4x squared? Negative 4.
So you keep it even though that's.
Mm-hmm. Oh, no, you're right. Sorry. Negative 4. It's got to stay in that column. So you don't have an x term. That's okay. All right, multiply around. Negative 4 times x squared. Negative 4 times x. Oh, I see why y'all asked that. We are going to have to bring down that term too. Negative 4 times negative 2. Positive 8. Come on. All right, change all your signs. First ones cancel as they should. The second ones cancel here again, which is nice. 14 minus 8 is 7, 6, 7, 6.
6. I was like,
So that is my remainder, right? Yeah. Go ahead, Indias. The reason you have to do that is because that middle term canceled out there, and sometimes things like that will happen. You normally only bring down one term at a time. But if you need another one, that's okay
I
too.
thought your remainder went on the bottom.
Remainder goes on top, what you divided by goes on the bottom. Okay, so your answer, your solution to this is it equals
X squared minus 4.
x squared minus 4 plus 6 over x squared plus x minus 2.
Did you do,
No r's.
yeah, you can simplify it?
That is simplified. That's the answer.
Could you just do negative?
Look across the top, x squared minus 4. And then my remainder over what I divided by.
Could you simplify the remainder?
No.
So you can't do
The
6
6
but divide by
over 2?
negative 2?
No. Because that's only, if the 6 was in the bottom, you could split it into 3 fractions, but because it's not, no.
Yeah,
Is there a way that you?
Now. No. You could factor the bottom, x plus 2, x minus 1, but it's not going to do you any good. If you multiplied back out. So,
Well, we have to do that.
no. All right, now I show you all this to get to a shortcut that works sometimes. You will need to do it because what we'll get to a section. Everybody always says, nope, I understand long division. I'm not learning another way. I'll just do it long. You will be shooting yourself in the foot
So
if you do
it's
that.
Just like perfect split.
Because there will be, yes, there, but this even more so important because there will be times where you will be given a polynomial and you will have to just start randomly dividing by certain numbers, and it could be 10 different division problems before you find the right one. And if you're not using the shortcut, if you have to do 10 long division problems before you get to the right one, you've used all your time finding what you were looking for when everybody else used the 30-second shortcut and we're done like that. Okay? Kind of. All right, so the shortcut, here's the deal. It only works when your pen does. Only works when you divide by x plus a number or x minus a number, okay? There cannot be any coefficient or exponents on anything. So look at that very first problem we did. That very first problem I intentionally set up so that it would be, this is called synthetic, by the way. I should have put synthetic instead of shortcut. This is called synthetic division. The very first one that we did looked like x squared plus 3x minus 40 divided by x minus 5.
So
Yeah.
it wouldn't be like x minus a? No, that's not like that.
What did we get when we divided this?
We
It
got
wasn't-
X plus 8.
X plus
Okay.
X minus.
All right, here's what we're going to do when we set it up. Now, don't shut down on me. You ready?
Yeah.
We take this number. We change the sign.
Even when it's positive?
Yes, change the sign. We do an upside down division sign with enough space for 2 rows of numbers. I know nobody likes it when they see it the first time, but they love it after they work with it a little bit. I have a lot of sour faces right now. Okay, the very first row in this, okay, there's 2 rows of numbers, right? It's going to be the coefficients of that first polynomial. But you have to remember placeholders. Coefficients with placeholders. This is a super, super easy first example. I mean, all synthetic is easy. All right, here's what we do. 1, 3, negative 40. If there was one missing, so remember that one I showed you that had 5, 4, 3, and then we did 0, 0, 0? Yeah. All right. Drop down the first number. Multiply. What's 5 times 1? Write it here and add this column together. So 8. Do it again. Multiply and add. If I had another column, I would continue with the pattern. So it's drop, multiply, add, multiply, add, multiply, add, multiply, add. Okay? This has been divided now, and you just need to interpret the answer. Yes.
So with the 5, like going under the 3 and then the 40, like where did you do that from? I thought the negative 5 in the first problem would go under. Oh wait.
The only thing the 5 does is go outside right here.
So then
And you're done with that piece after that.
So where did you get the other
Yes.
5 from?
So it's just.
What other that's I dropped this first term, multiply by what's on the outside, and write your answer there. This 5 has nothing to do with this 5. This is multiplied here. I'll show, once you see a couple of them, you'll catch the pattern very fast. I'm used to this. Everybody sees the first one, goes, and then they see the second one, they go, okay, and then they see another one, you go, oh my gosh, that's easy.
So where do we put the X box in there?
All right, so how do you interpret this to the answer? Look at what my original answer was and look at what I have here. This column, now this one you have to start from the right and move to the left. This is my remainder column. This is my constant column. This would be x. If I had another column, guess what it would be? X squared. If I had another one, and it would keep going up that way. So my answer to this is 1x, look at there, plus 8.
You got a remainder.
You would put it over x minus 5.
So if you had a remainder, you put it over the original.
Yeah. All right, let's do another one.
Wait, can you say that one more time? If you had a remainder, you do x plus 8 over your remainder? Over whatever your remainder is?
You do remainder over x plus 8. Or you do. Let me show you one with a remainder. Let me show you one with a remainder. Yeah. Shh, can I what? I can't hear you. What? Yes, yes, yes. All right, let me show you one that's got placeholders and a remainder. 4x to the 4th plus 2x squared minus 4x plus 12 divided by x plus 2. The first question is, can I do this with synthetic division? Why? But can I use synthetic division for this? Yes. How do you know?
Because
X plus a number, period. That's it. Okay? What goes on the outside of the opposite? So it's negative 2.
But don't we need to add our placeholder?
We're going to put our placeholders in. You don't have to add it here. You can add it as you set up. Synthetic is quick, easy, down, dirty division. It's just, you don't have to do a whole lot of extra stuff with it. Okay? All right, so I'm going to start 4. But look, I'm missing a power of 3, right? So I'm going to put a 0 there. I've got a power of 2, of 1, and a constant. Do you see why the 0 is there? It's holding the place for that column. All right, y'all ready? Drop down the first one. Multiply. What'd you say? No, the 0 has to come first because this is powers of 4, 3, 2, 1. All right. Negative 2 times 4 is negative 8. Add. Multiply. Add. Oh, thank you. Multiply. Negative. Do y'all hear that?
I paused it.
Did you get it up to the C?
Hello, this is Mary. So then you do negative 4 plus negative 36 and you get negative 40.
Write that down.
That's too loud.
So now negative 2 plus negative 40, what's the answer? What?
7.3 multiplication.
Oh, sorry, times. So times
It's just 80.
should be positive 80. Oh my gosh, Miss McGee, this pen stinks. Plus,
You talking about my pen? I told you.
yes. And then 12 plus 80 is...
See why I bang it on the side? Hit it on the side sometimes. You see my pain now, right?
This is hard. Okay,
Okay, so interpret your answer.
So remainder is 92.
yes,
Constant's negative 40.
yes.
18x, negative 8x squared,
How do you write it?
4x
That's
to
what
the
I'm-
third.
Okay, so this is the remainder. Yeah, this is like really hard to write. And then this is the constant. So when you write it,
Wait, shouldn't, since the 0 was the placeholder for x cubed, shouldn't that be x cubed?
No. Because the first one always cancels.
Ms. McGee?
Good morning, Canyon High School. It's time for the morning announcement. Please stand for the Pledge of Allegiance.
oh wait, hold on. I know.
I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all. Please be seated for a moment of silence.
It's negative.
Thank you. Congratulations to the volleyball team for defeating Emerald last night in 3 straight sets to win the first round of playoffs. Grace Montgomery led the team with 11 kills. Olivia Bishop and Meg Montgomery led the team in serving. The Lady Dogs will travel to Chesney on Monday to play round 2. Congratulations to the girls tennis team on its 5-1 first playoff day.